Hello and welcome back to your week 3 lesson 2 video where we're going to look at file name expansion and quoting special characters. Two very useful things. So we're going to look at the purpose of file name expansion. We talked about special characters a little bit briefly previously, and I said I think it was last week we talked about them. I've mentioned them a few times, and I kept saying there were content for another week, right? Well, that week is now, at least in terms of file name expansion. So we're going to look at a bunch of special characters for that and some demo on that. We'll look at how to quote special characters. So sometimes you want to use like the literal special character, right? So you can do that, and we'll look at a demo on that. All of this maps to your tutorial 3, investigation 2 and 3, and practice questions 9 to 13. Not 19, 9. So file name expansion is useful because sometimes you want to look for all files that match a particular pattern. Maybe they have a particular extension. We've got an example here, right, where we have a bunch of files that end in text. And to view just those files, if you don't know what's in the directory, you're going to want to use some shortcuts to find your way around those, right? So in this example, we've got files a.text, b.text, c.text, 1, 2, 3, abc, and work.text. So they all end in .text extensions. They're text files, presumably, right? We learned last week that the extension is for us, right? Linux doesn't care. So if you wanted to list, to get a directory listing of all the text files in your directory, and you happen to know stuff, even if you did know all of the files in the directory before issuing the ls command, which generally you don't, this would be one way of doing it. What happens if you don't know what text files you've got there, right? Well, we could use some special characters here, right? And file name expansion. So ls star.text will give us anything, any file in the current directory ending in a .txt extension, and it doesn't matter what's in front of that. So that's one of the special characters we can look at. So some common file expansion special characters that we use are star or asterisk, which represents 0 or more characters. Question mark will represent exactly one character, but this is any character. You can use square brackets to represent a range of characters, or character class as it tends to be referred. So it's kind of like the question mark, but with restrictions. Now, question mark would match literally any character, right? But if you wanted just letters, for example, you could do square brackets A to Z. And that would be, if you do it with lowercase letters, that would be just lowercase letters. Hopefully that makes sense. And if it's, if you wanted numbers, square brackets 0-9 would give us the range of numbers between 0 and 9. You can also invert that by putting an exclamation mark inside the square brackets before whatever character class you're looking for. So it would be anything opposite of that, right? It would be the inverse of your character class. So how does this actually work? Well, it works through a process known as globbing, or file globbing. This is a feature provided in Unix and Linux to represent multiple file names by using special characters, also called wildcards, with a single file name. A wildcard is a symbol which may be used to substitute for one or more characters. So we can use wildcards for generating appropriate combinations of file names based on what we need. And if you want some handy examples of how this works, check out that link there. It's in the slides. I would paste it into chat, but I do not have chat right now. But yeah, go check it out. I'll show you some really cool uses of this. So how exactly does it work? Well, we've got a diagram on the side here. We're issuing the ls command with star .txt in this particular case. Bash will search all of the files in the current directory when you execute this for any file that ends with .txt. So it replaces star with the name of the file that ends, or with any name of the file, sorry, as long as it ends in .txt and it's in the current directory. Now you don't see this happen. This happens entirely behind the scenes. You just see the results. Let's take a look at some of this in action, shall we? So I'm gonna demonstrate some stuff for you. I'm in Matrix. I'm still here from recording the last video. We're gonna create some files. I'm gonna just clear my screen just to clear things up from the last one. So first I'm going to use the touch file. I'm going to make a bunch of text files here, and some not text files too. Again, these are just empty files. The extension doesn't really matter. It's just going to be a text, an ASCII text file. But I want some other extensions, so I can show you some cool stuff with shell expansion. So I'm going to create abc.text, 123.text, abcd.text, efg.text, 321.text, cde.jpg, and 567.mpeg. And I'll issue an ls to confirm. So we see we've got some JPEGs here, we've got our MPEG, we've got our stuff from last week too. Now, remember, these aren't actually JPEGs and MPEGs. If I were to issue the file command on them, for example, we see it's just an empty file, right? Because that's what touch did. They're just empty files. These are purely for example purposes. So let's say I wanted to do an ls. Well, let's do star.text first of all, right? So I want just the text files in my current directory. I don't, because maybe you've got a whole bunch of files here, and you just want any file that ends in text. There you go, ls star.text. Same thing for JPEG, and the same thing for MPEG, right? So some simple, really simple things off the bat. Now let's say, for example, we want something a little more complex than that. We want any file that is 3 characters followed by text. So 3 question marks. We get 1, 2, 3. We get 3, 2, 1, ABC, EFG, and etc.text, which that's left over from last week, but it works fine in our example. Maybe we want 4 characters, so let's throw a 4th one in there. So you see, now we're going to get only files that have 4 characters in their file name, followed by .txt. Now for a more kind of practical usage on where you tend to use these, because you tend to use star more often than not. Oh, I want to use some character class first. Then I'll give you the practical example. I want to move some stuff around. Show you some cool stuff in a bit. Let's say we want files that begin with 0 to 9. Three times. I could do that, right? So square bracket 0 to 9. So each one of these represents a single character, but it can only between 0 to 9. So we get similar to our 3 question marks there, but you see we only get our 0 to 9. I could also do a character class for letters, so that would be A to Z, A to Z, A to Z, whoops, etc.text. And there we go. We only get our text files that are 3 characters consisting entirely of letters. So really, like, you're going to use these in context based on what you need, and you're going to get some more practice on this through the tutorial content this week. Some final handy things. I'm going to create some directories, and I'm going to move some files using shell expansion. I'm just going to use the asterisk in this case, and it's going to clean up our directory a little bit because it's getting a little busy here. We got a lot of stuff going on. So I'm going to create 3 directories: pictures, videos, and text. I'm going to move star.jpg into pictures. If I ls pictures, I can confirm that worked, right? And if we look in our current directory, yep, it's gone. Next, I'm going to move that mpeg star.mpeg into our videos directory. And I can confirm it's gone, right? And if I look in videos, there it is. And then I'm going to move all my text files into that text directory, right? So mv star.txt into our text directory. And there we go. Everything's been decently cleaned up. And I think I'm actually going to move etc.text back to our current directory. Oh. Because it's in text, right? Back to our current directory. So we see we represented that by a single dot. And there we go. So hopefully that helps a bit. I would just move that back for later, because I might want that later for some reason or other. So hopefully that helps make shell expansion make a bit of sense. And we're going to move on with our slides. So command history, another really useful thing. Bash stores, and we've already sort of looked at this a little bit, right? Bash stores all of the recently executed commands that you've issued on the command line in a hidden file in your home directory called bash_history. And you can scroll through this history from the command prompt using the up and down arrow. And you've seen me do this many times in class, right? I issued a command, I made a mistake because I make mistakes. And you're going to do this too. So you hit the up arrow, you correct the command, and you're good to go. Well, what happens if you go too far? You can go down, right? To go to the next one if you go too far back. There's also some other handy commands there. We can issue fc-l, and that will give you the last 16 commands that you've issued. And you can actually just use the history command, and that will list all of the commands that you have issued. I think it stores the last 100 or so. So that could be useful, especially when we get into some more complex commands later, where we're going to do some piping and things like that, right? Where you're taking the output of one command and piping it using it as the input of another. Now that's handy in and of itself, but you would still then have to like retype it out or copy paste or whatever, right? No. You can use, as we'll see in the history output, each command has a number beside it, and it's sorted numerically based on when it was used most recently. So you can issue an exclamation mark and that number, and it will re-execute that command, which is really handy. I use history all the time for that reason. Now, if you happen to know how the command started, and you don't even need the number, you can just type exclamation mark and the first couple characters of the command depending on how common it is, right? And Bash will execute the last command that you issued starting with that string. So that could be really handy too. I use this one all the time at home. We're going to see examples of all of these. And then finally, we looked at special characters. Well, sometimes you want literal special characters, right? So question mark or star. You might actually want a real one to appear. So to tell Linux to ignore that special character and treat it only as regular text, you have to quote it. Or suppress shell expansion is the other way of looking at it. And we can do that in one of three ways, as we're going to see. You can quote a single special character by putting a backslash in front of it, and that will tell it to quote that single character. This works for all characters. If you've got more than one character in the string, well, you could quote every single special character in the string, including spaces, or you could just encapsulate your entire string with single quotes, and that will suppress all shell expansion. But maybe you want some shell expansion. And we're going to look at this more when we look at scripting, and I'll show you an example of that today, where we're going to do some stuff with scripting and variable expansion, because that's something my programming students in this course will have learned in IPC already, is variables. So you can use double quotes, and that will suppress most special characters, but not all. It still allows variable expansion, which is handy. Could be very, very handy. So let's have a peek at those, shall we? Just going to move this around. There we go. So we got a few things to look at here, right? We have displaying text. Yeah, we got all kinds of stuff with special characters and quoting special characters. Well, I did some special character stuff with moving some things around. So let's look at the history. Right? Yeah, I got everything here I need. Let's just clear up my screen. So history, again, going up and down through the up and down arrows. There we go. There's everything that I've done recently. But maybe that's not what we want, right? So we can look at the last 16 commands with fc-l. There we go. And as promised, there are the numbers in history that correspond with when they were used. I can also issue the history command. And you see, it's got a ton of stuff, doesn't it? Just how long does this thing go back? Let me scroll up. It looks like quite a ways. Let's go all the way back to 1 on my screen. Oh, it does. Look at that. So that's obviously not the first command I've ever executed in Matrix, but it's quite a ways back. That's back in July of last year, and it went from 1 to 2,993. So I'm not sure exactly how many commands are stored in the history buffer. You could pipe this to more or less to see. But well, we could do something like, let's say we want to reissue this ls command. Or maybe I want, I don't think I have any text files here. Maybe I want this one here. I'm not sure if this is going to generate anything. So I can type exclamation mark 2976. And look at that, it did. It lists the command, and then it lists the output of the command. So that's super handy, right? Let's say we want the trying to think of something that would be good from our history here. Maybe we want that touch again. So I can type !touch, and it will reissue the last command that I began with touch. So super, super duper useful. And if I issue an ls to confirm, well, that worked. Now I'm going to have to do some tricky RMs here. I want everything except etc.text gone. So let's do 3 numbers. Is this good review? And really dot anything. I'm going to get rid of that JPEG. And I'm going to get rid of anything beginning with an a.text, and finally I can just remove efg.text because I wanted to keep that etc.text. Might be useful later. So like that, pretty handy. And then finally, quoting special characters. So for quoting special characters, I'm going to give you a preview of something we're going to look at a little bit later in the semester. Variables in Bash are, trying to think of the way to put this. Variables in Bash and variables in anything are just a name that's used to store something in memory that you can recall it from later. It's really handy for storing data and things. And we're going to learn about this later in the course, so don't worry too much. It's the quoting special characters element of this that I want to show you. So I'm going to issue a command here that will set a positional parameter, the first positional parameter, to equal OSL 640. When we call scripts, we call them with positional parameters, just like when we issue commands from the command line, right? ls-l. That -l could be thought of as the first positional parameter. So I'm going to set a positional parameter of ULI 101. And that's stored in 1. Now I can echo that out, or I can print that out using the echo command, which I don't think we've looked at yet, but we will be. By issuing $1. So the value of, this is what the dollar symbol means, the 1, our first positional parameter. And there we go, we get ULI 101. Pretty cool. But what happens if I want to quote that special character? Let's take a look at some examples of that. Maybe I want a literal $1. So if I put a backslash there, I get pretty neat. I could also do that with quotes. But if I put, look what happens when I put single quotes around that. Whoa, it expanded our ULI 101 there. That's interesting. So the single quotes suppress shell expansion and special character expansion for variables, but double quotes allow it. But they suppress other special characters. They do some others. The variable I can think of is a good example there. We can also print out $1 is $1. Well, that's kind of useless. It's not really going for what we want. I was trying to print out like the value of our first variable is, our first positional parameter is ULI 101. So let's see what happens if I put double quotes around that. Might work, might not. I don't think it's gonna. Nope. See, we got another useless kind of string. But what happens if I recall this, and within that I quote the first $? That's pretty handy. So now I've got the value of my first positional parameter is ULI 101. And I don't have to do anything to get rid of that. It will disappear when I log out. I could type the unset command, which is something we're going to learn later in the semester, and then it's gone. It's totally... It should be gone. That's interesting. That's really weird, because that should have gotten rid of that. But it will definitely be gone when I log out. So we did kind of all that, right? All of this maps to tutorial 3, investigations 2 and 3, and your practice questions 7 to 9. So that wraps it up for your theory for week 3. Thank you for watching. Take care. Be safe. Have a wonderful week. I will see you in this week's lab class. Bye for now.